In the topic of finding the maxima and minima, what we are interested in is the point at which we have the maximum value for f of x or the minimum value for f of x. So one easy method is to represent the entire function as a graph, and then we can find out the point at which the slope of the tangent is 0, right? So which means if you observe this, if there is a curve like this, okay? Now let's say this is the point at which the function f of x is maximum. Let us say this is f of x and this is x, okay? Now this is the graph plotted between x and f of x. Now if you observe this, this is the point at which we are having the maximum, and if you try to draw a tangent at that point, the slope of the tangent will be, this tangent will be parallel to x-axis, and so the slope will be equal to 0, right? Therefore, if you try to find out at this point, let us say this point is a, okay? Let us say this is f of a. Now at this point a comma f of a, if you try to find out the slope of the tangent, that is going to be 0, right? So what is the slope of the tangent? F dash of x at the point a, that is why f dash of a, right? If f dash of a happens to be 0, then we are going to have the maximum value there. That is why this point is very important for us, and such points we call them as stationary points, right? And also if you want to see even a point, even the point at which f of x is having the minimum value, the least value, there also the slope will be equal to 0. Therefore, in order to find out either maxima or minima, the main interesting point is stationary point, right? Now let's see that if f dash of a equal to 0, then f of a is the stationary value, and the stationary point is a comma f of a, and f of a should exist, right? So it means that this particular value, this is either the maxima or minima, that value is called as the stationary value, and this point is called as the stationary point, right? So that is what we really use in this topic. So sometimes what happens is there is one more point which is called as critical point, and according to the definition of critical point, every stationary point also happens to be critical point, and so in the questions, instead of asking about a stationary point, they are sometimes asking about the critical point. The reason is every stationary point is going to be a critical point. Now if you look at the definition of the critical point, you will understand that. Now see this, we say that x equal to a is a critical point of the function f of x if f of a exists and either of the following are true. So f dash of a equal to 0 or f dash of a does not exist. Now if you look at the definition of the stationary point and critical point, every stationary point satisfies the definition of the critical point. The reason is, for every stationary point f dash of a equal to 0 and f of a exists, right? Therefore it so happens that every stationary point is definitely going to be a critical point, right? And sometimes what they are trying to ask is, instead of talking about the stationary point in the questions, they are talking about the critical point. So coming to the topic of maxima and minima, either if they ask you about the critical point or stationary point, you just take them as one and the same and solve the question by using the same definition of the stationary point. You just find out the points at which f dash of a is equal to 0, and from that you find out the stationary point, even though they are asking about the critical points, right? And also remember that every stationary point is a critical point, okay? Fine. Now let's look at the functions, types of functions. Now based on the way a function is growing or decreasing, we can classify functions into various types. So it is all based on the values of the functions at various points. Now a function, let us assume that this is the function you are talking about, you can say that within this range x1 to x2, which means from here to here, you can talk about the function. If it is increasing, you can talk about it, and if it is decreasing, you can give it some name, right? So one of the classification is monotonic functions. So see this, a function f from a to b to r. So f is a function which is taking values in the range a to b, and it is giving real numbers as the output, right? Is said to be monotonically increasing or non-decreasing on a comma b if x is less than y implies f of x is less than or equal to f of y. So what they mean to say is, if you are having a function within the range, let us say a to b, then it should either be same or it should be increasing, or it should be same or it should be increasing. If you have such a function, then it is called as monotonically increasing, right? So what it means is, it should not decrease at any point. It could either remain same or it could increase, right? Now if you observe this one, so even the function is like this. In this case, I'll just maximize it. It is simply showing something like this, right? It is increasing at all the points, or it is remaining same. So in that case, it is called as monotonically increasing. Now what is strictly increasing is, you are not supposed to have this kind of growth. You should always have it in the increasing, right? So which means between a and b, if you are going to see, it should be of form like this, right? Or even if it is growing, it is not a straight line, it should be increasing. There should not be any points, 2 points which are equal, right? So which means like this or like this, you should not have any points there, right? Now see this, strictly increasing on a comma b means, if x1 is less than x2, that implies f of x1 is less than f of x2 for all x1 comma x2 belongs to a. So if you observe the difference between this one and this one, here whenever two values are equal, it is allowed, but here you don't have any points which are equal, which means it is definitely increasing, strictly increasing. Here it is either remaining same or it is increasing, alright? That is the meaning. Now let's see monotonically decreasing function. So if it is monotonically decreasing, it means that it could either remain the same or it could decrease, or remain the same or it could decrease. If a function is behaving like this, then it is called as monotonically decreasing, right? Now if you see this in this diagram, so we have drawn the diagram like this, and now we are saying that this is monotonically decreasing because it is actually decreasing and not increasing, right? So if it is non-increasing, you can say that it is monotonically decreasing. See, you should understand the difference between these two. So non-increasing means it could even remain same. So it could either remain same or it should decrease, but it should not increase. That is the meaning of it, okay? Now they are defining it on a range. See, even though the function is may increase or decrease in the other range, when we are talking about a range, what we mean to say is, let's say a and b have to be defined, right? Yeah, so let us say this is the a, this is a, and maybe this is b. Now if you see in AB, you take any 2 points, as we are going forward, it is either decreasing or remaining the same. It is never increasing, right? And what about strictly decreasing? Strictly decreasing means it should behave like this, right? As you go forward, it should always decrease. That is called as strictly decreasing, right? And now if you see this, here also, there is no point at which it is increasing or remaining constant, right? It is continuously decreasing. That is why it is called as strictly decreasing. So that is the main difference between monotonically decreasing and strictly decreasing, okay?
Hi, if you are planning to do masters, then doing masters abroad is better than doing masters in India. I'll give you all the reasons. So first reason is, out of 1 lakh students who take GATE every year, there are only 500 seats in old IITs. So all the IITs put together have an acceptance rate of 0.5%, and IITs, universities better than IITs, they have very good acceptance rate like 30%, 40%, but all the IITs put together have an acceptance rate of 0.5%. And if you are working hard to get into IIT Bombay's ranking is 177. And IIT Roorkee's ranking is 400. If you are happy to get into IIT Roorkee, then getting into universities better than IIT Roorkee is easier compared to getting into IIT Roorkee. And looking at the salaries for computer science, for software jobs, if you have done your masters in computer science in US, the salaries are ranging from 80 lakhs per year to 1.2 crore per year. So even if you take an average of 1 crore per year, your savings will be much higher than the salaries in India. After taxes and your cost of living, you can easily save 40 to 50 lakhs per year. And in India, the maximum jobs that you get is around 30 lakhs. So your savings will be much greater than the salaries in India. And these are all the services that we provide. University shortlisting. So depending on your profile, we will shortlist what are the universities that you have to apply, and statement of purpose building, and then LOR guidance, and GRE and English test assistance, and education loan assistance. So you don't have to have any collateral, which means without any security, now you can get education loan. Getting education loan is very simple these days, and whatever the amount of fee that you have a range of universities. You can apply for 10 lakh universities, 20 lakh universities, or 50 lakh universities. But whatever it is, you are going to get complete education loan, and you can pay off your education loan in 1 year after you get a job. And then we do visa assistance, mock visa interviews, and then connecting with the university alumni. So now you might ask why we should join Game of Visas. So the answer is we have 90% success rate, 99% success rate. And these are all the destinations that we guide the students to. So we guide students to any country that you want to go. So now it is not just USA. We guide to UK, Germany, Australia, Canada. So we guide students to all the countries. We work with all the destinations. And if you are interested in going abroad, you have to just drop us a message on this WhatsApp number 9494 555 454. Okay, thank you.